Have you ever solved an equation like this, then checked your exam feedback only to see half correct? But why? Welcome to the balancing of equations, where every platform unlocks a new math skill. Next up, simple quadratic equations. In this video, I'll walk you through two critical keys that break down the critical information on this skill. Together, they'll make sure you get every mark in your exam. In this section, you will discover a new equation, learn how to identify it, and learn how to solve it. Imagine an unknown number n. Now multiply it by itself. What's the short way to write this? Yes, this is where index notation steps in. We call it n to the power of 2 or n squared. Now let's build an equation. Let's say this equals 25. Now pause for a second and think. What is a number that if multiplied by itself will equal 25? Most say 5. And yes, that's correct. 5 times 5 does equal 25. So we're done, right? Hold on, these equations are quite sneaky. There is a twist. Is there another number that also works? It seems very obvious after you know. Well, -5 also works. Remember, when we multiply a negative by a negative, this gives us a positive answer. So -5 times -5 gives you positive 25. Now, this is your first introduction that equations can have multiple solutions. One equation, but two answers. This happens when the variable is squared, and we give these equations a name, quadratics. Let's now shift to strategy. What's the process to get to your solution? Think about this. So if this is squaring a number, what is the reverse process of squaring a number? Exactly, we take the square root. So if we had this question, we take the square root to both sides. On the left-hand side, the square and the square root cancel each other out, and we're left with just n. On the right-hand side, the square root of 25 equals 5. But remember what we discovered. We need to always show both solutions, the positive and the negative answer. A shorthand way to write your solution is as follows, which literally means my solution can be the positive or negative version. In this section, you will discover where these equations are used in the real world. Ever watched a soccer ball bend through the air? Or a basketball arc perfectly into the hoop? What about the rise and drop of a roller coaster? That's not luck, it's maths. Specifically, quadratic equations. They're behind every curved path you see. They help engineers build safer bridges. They help athletes perfect their shots. They help NASA predict rocket trajectories. Quadratics don't just solve problems, they model the world. Beneath every smooth curve is a formula, a graph, a story told in numbers. We'll uncover how these curves are drawn soon in a later topic. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.